Okay, please open up your packets to page 26 and complete the 4-question warm-up on factoring. So go ahead and pause this video while you do that, and once you've given yourself about 3 or 4 minutes to complete this, then turn the video back on. Okay, this is factoring a trinomial. We're pulling out always the GCF if there is one. So the greatest common factor here is x. You divide it out of each term, and you end up with x squared minus 9x plus 20. Then we are factoring to find the factors of 20 that add up to negative 9. So two numbers that multiply to give you 20 and add to give you negative 9. 1 and 20, 2 and 10, 4 and 5. This is going to be negative 4 and negative 5. So this is x times x minus 4 times x minus 5. Question number 2 is not so simple because we have a leading coefficient of 2 that cannot be factored out. So this is where we take the factors of a times c, 2 times 21, which is 42, that add up to negative 1. So that is going to be 7 and 6, if it's negative 7 and positive 6. And then we factor by grouping. So this becomes 2x squared minus 7x plus 6x minus 21. Pull out the GCF of each pair. So this is your factoring by grouping that you do from there. And this is x times 2x minus 7 plus 3 times 2x minus 7. And so this gives you 2x minus 7 times x plus 3. Needing to know how to factor is very important for today's lesson. What we did yesterday was we did problems where we discovered holes in our rational function, and now we are going to discover holes, but first by factoring. Yesterday they were already factored for you. For these two terms here, 5x plus 40, it's a binomial. We always look to see if we can pull a GCF out, which we can. We divide each term by 5, and we're left with x plus 8. So it's 5 times, in parentheses, x plus 8. This is a binomial, but it's a minus in between, so anytime we have a binomial with a minus in between, we're going to see if we have the difference of two perfect squares, which we do. So the square root of 9x squared is 3x. The square root of 25 is 5. And one is going to be a plus, and one is going to be a minus. So that's the difference of two perfect squares. All right, go ahead and turn to page 27. We are only going to get 3 problems done. We're not going to do all 4 of them. They take a good long time to do. Okay. All right, here we are at the top here. And what you're always going to do when you start these problems is to simplify completely and factor. So here we have x squared minus 6x in the numerator. So we're going to pull out the GCF of x, and it's going to be x times x minus 6. Then in our denominator, we're going to pull out our GCF of x. And we're going to have x squared minus 8x plus 12. So we're going to keep factoring that denominator because that's a trinomial that can be factored. So this is x times x minus 6. And our denominator is an x times, again, our leading coefficient's 1, which is good because it makes for easier factoring. We're looking at the factors of 12 that add up to 8. 1 and 12 and 2 and 6. And 2 and 6 are going to add up to negative 8. So x minus 2 and x minus 6. So when that happens, when we have this done here, this is f of x equals, it's a function. And we are now looking to see if we have any holes or vertical asymptotes. So to look for holes, we're looking for any factor that cancels in common here. So this is an x. So that factor would be x equals, it's going to have a hole at an x value of 0. This crosses out here, x minus 6. If you take x minus 6 and set that equal to 0 and solve, we're going to have a hole's x value at positive 6. Then to figure out what the y value is for each of the holes here, we're going to see what we have left here. This, once we cancel out, becomes 1 over x minus 2. So we're going to plug our 0 in. 1 over 0 minus 2 is negative 1/2. And when we plug a 6 in, 1 over 6 minus 2, and simplify, it's 1 over 4. So our wholes are at 0, negative 1/2, and 6 1/4. Now notice that this, once we now set equal to 0, since it didn't cancel out, is left as a vertical asymptote. So our vertical asymptote is at x equals 2. So x values where there are discontinuities. Well, we have a vertical asymptote at x equals 2, and we have holes at x equals 0 and 6. I know that's not in order, but it's fine. Our hole coordinates are 0, negative 1/2, and 6 1/4. We will be doing these again for the next 2 problems, so hopefully if you had trouble with these, you're going to start to get it when we do 2 more of these. Vertical asymptote is at x equals 2. X to the third doesn't go into x squared at all, so our horizontal asymptote is just y equals 0, goes in 0 times. Our domain is all real numbers except for any restrictions to the domain, so anything that makes the denominator 0. So this is going to be all real numbers, except x cannot be equal to 0, 2, and 6. If we actually put them in order this time. This is a function that is 1 over x. So you know it's going to be in quadrants 1 and 3. So this is going to be all real numbers except for our restrictions. Y cannot be equal to the horizontal asymptote at 0. And it can't be equal to the y values of the holes. So in order it would be negative 1/2, 0, and 1/4 that it cannot be equal to. Now in terms of graphing this, we had a vertical asymptote at x equals 2. I'm just going to dot that in. Make sure you're always labeling your asymptotes. We have a horizontal asymptote at y equals 0. At 0, negative 1/2, we have a hole. And at 6, 1, 2, 3, 4, 5, 6 1/4, we have a hole. So we know what quadrants we're in because the holes exist in those quadrants. So these are our graphs. Normally if you didn't have those points over there, you'd check a value on either side of the vertical asymptote to figure out which quadrants these exist in. Left end behavior and right end behavior is always going to approach a horizontal asymptote when it exists with rational functions. So as x approaches negative infinity, f of x is going to approach 0. Notice that it's approaching the horizontal asymptote at 0. As x approaches infinity, f of x is going to approach 0. Now our transformation here. All we noticed here is we took our function and it shifted 2 units to the right. We ended up with a 1 in the numerator, so we didn't have a vertical dilation. So this translation is just 2 to the right. Okay, for question number 2, this adds an extra couple double layer of difficulty here. Number 1, it's got a shift down 3 units, so that's going to affect our horizontal asymptote. We also have a more complicated factoring problem. Our numerator here, this is going to be g of x. Sorry about the crookedness here. G of x equals 3 times x plus 4. We're looking at the factors of 40 that add up to 3. And then you do your grouping. So that's going to be a little bit of work here. So you're looking at, I'm going to do this down here. The factors actually of negative 40 that add up to positive 3. So that's going to be negative 5 and positive 8. So I'm going to do this down below here. So this is going to be 2x squared minus 5x plus 8x minus 20. When we group, we pull out our x and we're left with a 2x minus 5. We're going to pull out a positive 4 and we're going to be left with a 2x minus 5. So this factors to give you 2x minus 5 and x plus 4. That's factoring by grouping, which is done by splitting the middle. 2x minus 5, x plus 4. Okay, then we still have our minus 3 here, hanging out. All right, so we're first looking for our holes, and in this case we have one hole. Our hole is when we take x plus 4, set it equal to 0 and solve it, and we get an x value of negative 4. That's the x value of our hole. To figure out the y value of the hole, what we have left here now is a 3 over 2x minus 5 minus 3. And we're going to plug this negative 4 in. 3 times 2 times negative 4 minus 5. Negative 8 minus 5 is negative 13. So this is 3 over negative 13 minus 3. And we need a common denominator here. So this is going to be 3 over negative 13 minus what, 39 over 13, because that's minus 3. And this is, let's see, what do we have here? Negative 3 minus 42, minus 39 is negative 42 over 13. So not only is it a complicated problem, it's got ugly numbers. And it doesn't mean it's wrong when it's got ugly numbers. So don't be concerned about that. So what I have left now, as you look at our function that's reduced here, we are left now with a function that is 3 over 2x minus 5 minus 3 once we kind of remove that whole. So we have a vertical asymptote when we take this denominator and set it equal to 0. 2x minus 5 equals 0 gives you a vertical asymptote at 5 halves. So vertical asymptote, x equals 5 over 2. So x values where we have discontinuities are at x equals negative 4, the x value of the whole, and 5 over 2. The whole we already discovered was at negative 4, negative 42/13. Horizontal asymptote. Okay, so this again is a bottom-heavy function. You can't divide this in, so it would be y equals 0 for this section, but we shifted down 3 units, so our horizontal asymptote is at y equals negative 3. Once again, this is a bottom-heavy function. It reduces kind of like, it looks kind of like a 1 over x function. Now, let's go ahead and graph what we have, just to be sure here. So what I have here is at 2.5 is a vertical asymptote. X equals 5 over 2. Y equals negative 3. And then at negative 4, and a little bit down here, we've got our whole. And if we plug the point into the right, it'd stick us up in this quadrant here. Again, you would just plug the point of, let's see, probably like a value like of 3 in there, and you'd see that it would be in this quadrant here. So our domain is going to be all real numbers, except x cannot be equal to the vertical asymptote at 5 halves or the x value of the whole. So not negative 4 and not 5 halves. The range is all real numbers, except y cannot be equal to the horizontal asymptote here and the y value of the whole. Once again, the end behavior is going to approach a horizontal asymptote. So as x approaches negative infinity, f of x approaches negative 3. And as x approaches infinity, f of x approaches 3. Transformation. So notice we shifted 5 halves to the right and 3 down. So 5 halves to the right, or 2.5 to the right, 3 down. And notice our numerator has a 3 in it. And that makes it a vertical dilation of 3. All right, flip on over. We're going to go ahead and do question, first question, top 28. And we're not going to do the second question at all. All right, so as I look at this problem up top and I need to factor, there's nothing that comes out of the numerator. There's no GCF that can be pulled out there. But you notice the denominator is a minus between a binomial, between 2 terms. So it is going to involve the difference of 2 perfect squares here, because 4x squared and negative 9 are perfect squares. So this is a 2x and a 2x. When I take the square root of 4x squared, this is a positive 3 and a negative 3, and then I still have my plus 1 hanging out here, which is going to shift our horizontal asymptote up 1 unit. So this 2x plus 3 cancels with this 2x plus 3 once, and what this reduces to now is like 1 over 2x minus 3 plus 1. So our whole, when we take 2x plus 3 and set that equal to 0 and solve it, has an x value of -3/2. Then we're going to plug -3/2 back in here. So this is going to be 1 over 2 times -3/2 minus 3, plus 1. And that is going to give us a y value of 5/6. Because that's going to be -3 minus 3. 1 over -6 plus 6 over 6, or plus 1 is 5/6. So seeing what's left in the denominator here, again, reduced is a 2x plus 3. So our vertical asymptote is going to be at x equals 3/2. I take 2x minus 3, set it equal to 0. Sorry, 2x minus 3, set it equal to 0 and solve it, and we get 3/2. So right now I have a vertical asymptote at x equals 3/2. I know my x values without discontinuities are the x value from the whole, which is -3/2, and this positive 3/2 from the vertical asymptote. Our whole is at -3/2 or -1.5, 5/6. A reminder, we're not using a calculator here, so you're going to have to do this math on your own. Sorry, whoop, just shook that. Horizontal asymptote. Again, this is considered a bottom-heavy function. X doesn't go into 1, so this would be y equals 0 plus 1. So our horizontal asymptote is 1. Y equals 1. And that's an equation, so you have to write it as y equals, and vertical asymptote is x equals, because it's an actual line. The domain is all real numbers except for your restrictions. Well, in this case, let's actually go ahead. That's not the complete answer. Let's actually go ahead and graph what we have right now. So we have a vertical asymptote at 1.5. So x equals 3/2. Make sure you label it. We have a horizontal asymptote at y equals 1. Again, once again, make sure you label it. At -1.5, 5/6, we have a whole. So if you plug in a value to the right of the vertical asymptote, like the number 2, and you simplify that, you're going to end up in this upper quadrant here. So our domain is going to be all real numbers except for the x value of this whole and the vertical asymptote. X value of the whole and the vertical asymptote. So it's all real numbers except x cannot be equal to -3/2 and 3/2. Range is all real numbers except the things that make, so as we go from bottom to top here, the y value of the whole and the horizontal asymptote. So this is all real numbers except for 5/6 and 1. Again, left and right end behavior is approaching that horizontal asymptote. So as x approaches -infinity, f of x is going to approach 1. And as x approaches infinity, f of x is approaching 1. So notice when we reduced this fraction here, we had a 1 left up in the numerator. So there's no dilation going on here that we have to worry about. We're going to just say that we went 3/2 to the right and 1 unit up. So what you're going to be doing next, find the right page, is your practice homework, which is page 29 and 30. So it's these problems here, page 29 and page 30. And that is the end of this lesson. Thank you.